Hey guys, how's it going? It's Carl again. This is week 11. Now we're getting into chapter 14, problem number 1. And this is kind of educational, just kind of showing you how to understand an Excel regression output. And we're just going to kind of walk through basically what you're seeing right here. So kind of the question is, the soap manufacturer tested a bar of soap to see how long it would last. A test subject showered with the soap each day for 15 days and recorded the weight in grams of the soap after the shower. Part of the regression output is shown below. And so we're just kind of getting a sense of, so what does all this mean? And just first off, standard deviation of the residuals. Where is that? In your output, this is what this is. This S equals 6.0, and as you can see, it's 6.0. Slope of the regression line. What is the slope of the regression line? The coefficient of the independent variable is the slope of the regression line. So the coefficient, what in front of, say, a given random point. So your traditional y equals mx plus b. In this case, the coefficient for that is m. And it's just phrased a little differently just because we're dealing with regression lines here, not just kind of your straight and narrow charts. So negative 5.56. Where is that? Right here. Your coefficients are right here. So this is your regression line, day. Why is this your regression line? Because as the question notes, you were looking and examining just the weight in grams after the shower for 15 days. So you're recording this in that aspect. Standard error of B1, your intercept. What is that? The standard error of the slope is the standard error of the coefficient column and the row for the independent variable day. So where is SC coefficient, standard error coefficient? Right here. And because we're dealing with our regression line here. That's key. We're dealing with the regression line right here. So next question is p-value rather, appropriate for testing a null hypothesis. Which p-value is appropriate for testing the null hypothesis that B1, the regression is 0 versus the alternative that it is not equal to 0. So where would we find it? What p-value? And as you can see right here, this is the p-value that we'd be dealing with, 0.0001. So in kind of moving down, we'll see determine if the null hypothesis is rejected at alpha equals 0.05. So looking at the p-value to determine the condition, if it's less than alpha, reject the null because the data is unlikely to have occurred by chance. But if p-value is greater or equal to alpha, fail to reject the null hypothesis because the association in the data is likely to have occurred by chance. So what we could do here is just kind of set it up just to show you, because Excel can do a lot of quick math for you, especially when you're doing multiple problems. So here's our first p-value. That's the p-value rather, 0.0001, and our alpha 0.005. So we have to make sure when we're testing whether or not that it's less than alpha. So in this case, we're just going to put an if statement, if you remember how we can do that. If condition logic test, if our value, which is this, 0.0001 is less than that, and just type in a traditional text, reject the null, just to give you a sense of what we're doing. And then here, fail to reject the null. So just giving you a quick sense of how this is done. And as you can see, because obviously visually you can tell, but just a sense that it's good to practice this, because depending on your experiment, depending on how much detail, depending on your data itself, rather, in the size of what you're studying, sometimes this won't be so cut and dry, and that you really have to just visually sometimes, or depending if you're actually looking at multiple multivariate regressions now, more complex models where you're actually using not one just variable, you're looking at several variables. A lot of that happens in population health studies and those kinds of things. So, but we hope this helps, and just let us know if you have any questions. Thanks so much.